Hello friends, today's topic of discussion in this video is the quicksort algorithm. So we have discussed many sorting algorithms in our previous classes. So in this class I am going to explain what is the quicksort algorithm. Quicksort is one of the many different sorting algorithms performed in the discourse of data structure in order to arrange or sort elements, unordered elements in an array. So quicksort is one of those techniques, and it is a technique which is of a divide and conquer type, and it involves the partitioning of the entire list which is to be sorted into two partitions. And in which way the partitions are being done, I will just show you by a small example, example data list by which I am going to show you how the partitioning is done, and after that I am going to write the C function of the algorithm and explain it line by line to you, so that you can understand the details of the quicksort algorithm in terms of the programming language. So let's get started with writing the example first, in which we will show you how to partition the elements in an unordered list in the quicksort algorithm. So I have written some elements over here. These elements are not arranged in a sorted order. So this is 33, this is 11, this is 77. They are arranged in an unorganized fashion, disorganized fashion. So we are going to sort this entire data list into an ascending ordered sorted array, and in the quicksort algorithm the technique involves the divide and conquer principle, and which helps us to partition the problem domain into two parts by partitioning them. And how the partitioning is done, I will show you by the means of this example. So this suppose for the first instance I will just encircle this 33, and I will just encircle the last element 66 in this unordered list which is given to us. So after doing that, what is to be done is that we will start scanning from the right to left. We will start scanning from right to left and stop at the element which is less than 33. Stop at the elements which is less than 33. So in this case, suppose 66 is not less than 33, 60 is not less than 33, 90 is not less than 33, 77 is not, suppose let it be like this so that it becomes a clear. Just make it 22 so that we can encounter less than 33, a number less than 33 at the at some of this after 2 or 3 elements. So I've just changed a bit over here. So 66 is not less than 33, 60 is not less than 33, 90 is not less than 33, 22 is less than 33. So 22, since 22 is less than 33, then what to do is that we will encircle this 22 and swap this 2 elements first and then encircle it in the next step. So suppose now we are going to swap this 33 with this 22, which is the first element, starting from the right to left scanning, where we encounter an element which is less than the leftmost number, that is 33. We get this 22 as that number. So we swap this 22 with 33 and write the next step of the list. Suppose, let me write it first and then get back to you. 22, 11, 33, 90, 60, 66. Now let us encircle this 33 and let us encircle this 22. Let us encircle this 22 and 33, and we will follow the same pattern which we have done in the previous instance, that is scanning from the right to left in that case, and in this case, in the next step, we will just do it in an alternating fashion. That is, now we are going to scan it from the left to right. We will go to scan it from the left to right and see which number starting from 22 is greater than 33. And stop at that number and then swap that number with 33. So now let us begin with 22. 22 is not greater than 33, 11 is not greater than 33, now we come to 33 and see that 33 is also not greater than 33. So, and then cross over this element. So, we cross over our range, and in this pattern we can see that since we cross over the range of 33, the demarcation, the delimiter 33, then in that case we will conclude that 33 has found its place in the correct position in the above list. When it is to be sorted finally, 33 will obviously occupy the position number 01, that is 2, position number 2 in the array, because 33 has found its position. So, we have got the 33's position now at the end of 2 steps of the execution of the algorithm, and in this way we can see that this element is called the pivot element. This element is called the pivot element, which has found its position now, and this pivot element helps us to differentiate between the 2 lists, helps us to separate rather between the 2 lists which have been created on either side of this pivot element. So, this is a sublist and this is a sublist. So, this sublist contains 22 and 11, and this sublist contains the values 90, 60, 66. So, in this way we can partition the entire list into 2 sub-arrays or 2 sublists with the pivot element in between. Now, what we have to do, it is a recursive algorithm and it is divide and conquer algorithm in a which we will approach in a recursive pattern, and recursive pattern will warrant something to be done on either of these 2 lists which have been created by placing this 33 in its proper position. So, now we will apply the entire algorithm which we have performed in the previous 2 steps in case of this sublist and in case of this sublist as well. So, let us take this sublist and write this sublist first. So, first it is 22 and then it is 11. Now, encircle this 22 and encircle this 11. Now, we will see, we will just follow the above first, the pattern which was followed in the first step. That is, we have seen that which number we have started scanning from the right to left and seen that which number is the first number which we encounter from right to left, which is less than 33, and stop at that position. We have done like that in the first step. Now, we will exactly do the same method over here and see that we will start from 11, scan towards the left and see which number we first encounter, which is less than 22. So, starting from 11 is the first number which we encounter, which is less than 22. So, we will just swap this 11 and 22 and write this 11 over here and 22 over here. Now, we will encircle this one and encircle this one and see, and we do the left to right scanning as has been done in the second step of the previous iteration. So, in this case we will do like this, that we will see, we will scan from left to right and see which element is greater than 22 starting from 11. So, 11 is not greater than 22, 22 it is same as 22, so 22 cannot be greater than 22, and we cross over, and after crossing over we see that we have crossed over the element to which we were comparing any other element which should have been greater. So, we did not find any element which is greater than 22 and cross over this 22. That means we have discovered the position of 22, and this 22 becomes the pivot element of this sub array, and it has a sublist on left hand side which is 11, which is a solitary element, and on the right side there are no elements. So, there is no question of repeating the same pattern on the right side, because it is an empty list, and in this case since it contains 11, only one member on the left sublist, it is easily assumed to be trivially sorted. So, it also needs no further swapping. So, it needs no further performance of the entire process which we are doing all this while. That is 11 will remain at this position. So basically I can say that this 22 and 11 on the first instance, the sublist which contained these two elements have been sorted, and now we come to this second list which contained 90, 60 and 66 and do the same algorithm and run the same algorithm as we were doing all this while. Now this see, we will encircle this 90, we will encircle this 66, we will start right to left scanning and see which value is less than 90 which we encounter starting from the starting from 66. So 66 is the first element, 66 is the first element which we see is less than 90. So we will just swap this 66 and 90 and write like this: 66, 60, 90. And now see this, 66 will be encircled once again, 90 will be encircled once again, and this 66 and 60 and 90 are now there, and we will start a left to right scanning and see which number is greater than 90 when we start from leftmost element of this sublist, that is 66. 66, it is not greater than 90, 60, it is not greater than 90, 90 is definitely not greater than 90. So we can conclude that we have discovered the position of this pivot element, that is 90. After which we see that there are no elements, and we can see that this pivot elements has been specified its proper position with a sublist on the left hand side containing two elements 66 and 60, and a right sublist containing no elements, that is an empty right sublist. Now this, nothing is to be done for the right hand side, but we have to perform the same algorithm for these two values separately. Now we write this 66 over here and 60 over here. Encircle this 60, encircle this 66. We will perform the similar pattern, that is we will start from right, go to left and see which is the first number which we encounter which is less than 66, and swap that number with 66. So in the first instance we see that the 60 is less than 66, and then we immediately swap this 60 with 66 to see that the list has become like this. Now we will encircle this 60 and again 66, start left to right scanning and see which value starting from 60 is greater than 66. Now 60 is not greater than 66, 66 is definitely not greater than 66 because it is equal to 66. So we can easily conclude that we have found the position of the 66 in this sublist containing two elements 66 and 60. So this is the pivot element containing an empty right sublist and containing a solitary member left sublist having only the element 60. So it can be considered to be trivially sorted. So 60 has found its position. So now we can see, so this list has become 11, 22, then comes this position which has found its position. So let me just sum it up: 11, 22, this position, this 33 has got its position in the first step, rather in the second step, 33. Now for this entire list, this has been sorted in the manner that is 90 has found its position like this, that is third of the three elements, and this out of these two elements which are on the left side of 90, the ordering has been done in this manner, 60 and 66. So let's put 60 and 66 over here. So we get a list, entire list in this manner, and see this list has been properly sorted in an ascending order, that is 11, 22, 33, 60, 66, 90. So it is clear, I think, to all of you that it has been sorted perfectly in an ascending order following the quicksort algorithm. So this is the approach of the quicksort algorithm as far as this example is concerned, this illustrative example is concerned. And now we will just go on to explain this algorithm in the light of the programming language, that is we will write the C function rather of this algorithm in the next part of this video.